everyone. I want to make sure, okay, the mic sounds on. Great. So I'm so excited to introduce Zan today. If you haven't seen some of her work, she creates visual forms to reveal or communicate in data across lots of different applications and disciplines, and really treating visualization as kind of a way to ask good questions, and her design is driven by these questions and important features for the particular question, scientific question that she's asking. Her work has won an Information is Beautiful Silver Award. It's been exhibited in Museum of Modern Art in San Francisco. Also has had work in Scientific American. And I learned that over lunch that she must have incredible grip strength and core strength because she did a kind of tandem circus act not too long ago. Yeah, and now she works with the Google Accelerated Science team, doing some of this work that she'll speak about today. So thank you so much, Zan.
Waking my computer up. Thanks so much for the great introduction. And there we go. Yeah, I really appreciate being here. Thanks so much for the eScience Institute for bringing me here today. I'm excited to talk to you all about data visualization for analysis and discovery. I'm a data visualization engineer and designer at Google. Here's some of the work that I did when I was a freelancer, just a scattering of some of the different projects. And currently I work with the Google Accelerated Science team. My goal is to use data visualization to enable scientific discovery in collaboration with a team of scientists, engineers, and quants. The team as a whole uses machine learning and large-scale computing and looks for problems in science where those are really appropriate tools, and collaborates with external scientists as well to apply those tools and also advanced machine learning techniques. So let's dive in. I'm just going to start by telling you everything you need to know about data viz. Pie charts are bad. Non-zero bar charts are bad. Dual axes are bad. Rainbows are bad. Chart chunk is bad. And a height to data ratio is bad. So I think we're good. I was wondering if there's any questions. These are the oft-quoted rules of data viz. As you get into data visualization, you might hear these. There's lots of blog posts about these. There's heated debates. And while I have opinions on all of these fronts, for or against, I don't think it's the most helpful framework about thinking about what we should do. It reminds me a lot about how we talk about food sometimes, that everything is bad for you. And that doesn't really tell you what you should do. Instead, I think it's better to have a few good guidelines than a bunch of rules telling you what not to do. For food, I really enjoy Michael Pollan's Eat Food, Mostly Plants, Not Too Much, which some of you might have heard about. For data viz, I don't have quite the oomph saying yet. I'm working on it, but I'll go with create small multiples, which are many related charts, use color intentionally, and optimize your charts for your time, energy, and attention. But before we get into those guidelines, is it good or bad depends on your goals, your context, and your constraints. You can't have a conversation about whether a chart is good or bad without understanding that larger context. And in the context of food, the question, is a candy bar good for me, might seem to have an obvious answer, because if I'm at home drinking tea, it's probably not the best thing I could eat. But if I'm on a week-long backpacking trip, maybe it's exactly what I need to get me through those next few miles. In the visualization context, these are both visualizations that I created, one for a talk on seasonality, one was published in Scientific American, a collaboration with Nati Bremer. Which visualization for what time of days babies are born is better? It depends. What is the point of the visualization? How much time did I have to create it? Who's the audience? What's their goal? Do I care about day of week, which is completely invisible in one of these charts and a major feature of the other one? Do I care about total values or difference to mean? And I would argue that actually, even though one of these charts is obviously much more polished, for each application, that chart was the right chart at the time and for that purpose. In a kind of a little bit more of a constrained perspective, even when we're doing analysis, these are 3 very similar charts about the wind speed versus wind direction in Bellingham, Washington. I pulled some data from NOAA that was applicable to this area. We have 2 different types of heat maps, one in rectangular coordinates, one in polar coordinates. Another chart that maybe is a little bit more intuitive, but also obscures some of the data. Which one is best? It depends what you're trying to do. In particular, I think one of these is better for seeing max values and the other is better for understanding the density of minimum values. I think the rectangular, it's easier to see when you have common mins, and I think the polar is better for kind of seeing the maxes and intuitive sense of direction. 2 of the major buckets for visualization are when we're trying to communicate and we're trying to analyze or discover, when we have exploratory analysis or kind of pipeline analysis. I think these often beg us to ask different questions. For communication, does it attract the audience's attention? Does it get the message across? Is it true to the data? Is there a chance that it's misleading? How much space do we have on the page or the screen? And is it immediately understandable? For analysis and discovery, the questions might be more, how much of your time and energy is needed to interpret it? If something is important in your data, will you see it? How long does it take to create? How much mental effort does it take to create? How hard is it to ask a new question? And will I look at this often? I'm looking at it every day. That's going to be very different than if I look at it once and never see it again. And I want to emphasize 2 of these in the context of analysis and discovery. One is that if something is in your data is important, will you notice it? And I think that it's in the context of analysis and discovery, it is okay to risk something looking important that isn't, because you're going to do more analysis, and you'd better do more analysis. But that it's a bigger risk to miss something important. That might be that next discovery that you need to make. Whereas if something looks important and it isn't, then you can do that next step analysis. You can check and see, and then you'd be like, oh, actually, that was an artifact. That wasn't what I wanted to see. Secondly, your time and your energy is your most limited resource. And I think that we often equate number of charts with time and energy, but there's a lot of times actually where you can have more charts that are well-designed, that are intentional, that are actually take less time to communicate, less time to understand what's going on. I think this is especially true in the context of like a data processing pipeline, where you're doing a similar analysis over and over, and you only create the charts once, and then you look at them every time you do the analysis. And they're having really intentional charts that serve a really specific purpose can actually take much less time to interpret than something that's fewer charts and more complicated. So is it good or bad depends on your goals, your context, and your constraints. I think this is true for food and visualization and engineering and machine learning and statistics. For example, there's no best statistical algorithm. There is no best machine learning algorithm. It depends on what you're trying to do. So you probably didn't expect to have to talk when you came here, but this is your turn. For the next 2 minutes, I want you to discuss with the person next to you what is one goal, context, or constraint that's important for a Viz project that you're working on. I know it's the beginning of the semester, so if you're not working on a project yet, maybe there's a chart that you saw that you liked or didn't like. What do you think was one goal, context, or constraint for that chart, or something else kind of in your world? Go. It's over here. Feel free to come back. There's seats over here. And there's some seats on that side if you're looking. your seats. Okay, the 2 minutes are up. If you can hear me, clap once. Awesome. Thanks so much. Is there anybody that wants to share a goal, context, or constraint? Putting you on the spot. Big lecture hall.
I'll share a context. So we were discussing one that I just saw the other day. It was one that was focused on looking at stock investments. And so for us to look at the class, at the career, it didn't make a whole lot of sense as to what it was trying to say. But for people that actually use it in the stock market, they use it for real-time updates. And so it made all the sense and all the difference in the world to them. But those who didn't think to use it, it made almost no sense at all.
Yeah. Awesome. And so if anybody couldn't hear that, I'll repeat on the mic. So context was graphs for the stock market that were real-time, people making real-time decisions. And if you've never seen it before, it made no sense at all. But for the people that are using it all the time, it made all the sense in the world. And that's a really different type of use case. And I think there's a really interesting world of visualizations where people are trained on it and there's something that they're using every day. Awesome. Thank you for sharing. Cool, so I'm going to dive in and talk about these guidelines that I mentioned in the beginning. So create small multiples, use color intentionally, and optimize your charts for your time, energy, and attention. I'm going to start with creating small multiples. What are small multiples? Lots of small charts that are similar to each other that you look at the same time. And I haven't told you what these charts are that you're looking at, but I bet without even knowing what they are, you can start comparing and contrasting them. You can notice that January is different than June. And you can notice that June and July have some similarities and some differences. And so even without any context, you're already using a lot of visual attributes to start making comparing and contrasting and making really rich insights, even having no idea what data you're looking at. I'll tell you what you're looking at in a little bit. So there's a couple different types of small multiples. The canonical one is when you have the same form, the same metric, and just different categories of data. So the one we just looked at was breaking things down by month. We're in Seattle, so I thought I would get some data from NOAA on Whidbey Island and ask the question, what direction does the wind come from? If you just create a chart, this is observations, hourly observations from the last year. Most of the time, the wind is coming from the east to south or from the west. But we can drill down by temperature. We can ask questions, does temperature correlate with wind direction? We can break that down into 4 charts, looking at when it's cold, less cold, warmer, or warmest, and see pretty quickly, yes, these are different charts from each other. There is some sort of correlation. This is the chart we just saw. Does wind direction at Whidbey vary by time of year? Yes, it does, in some ways. Again, these are all histograms. We can also ask a question, are other nearby stations similar or different? So here's a few different places. Again, some show similarities, some show differences. You can quickly start getting a richer sense of what the weather's like, how similar it is to other areas in this part of Washington. You can do small multiples with any type of chart. Here's an example of a polar heat map with wind speed and wind direction that I really enjoy. So wind speed, distance from the center, direction on the compass rose, and you can immediately see that Whidbey and Tacoma Narrows and SeaTac and Bellingham are different from each other, but there's similarities too. And you'll notice also when you're doing this, often you kind of strip out, you really want to focus on the data, so stripping out some of the axis information, and maybe you add some more back in, but really trying to keep it very clean to focus the comparison on the data itself. I'm using this in practice. This is an example from some of the science work that I've done with one of the teams at Google. I'm not going to really talk about what the science is behind this, but this is a tool where we have 48 charts. And I think people often get worried with small multiples of how can somebody look at so many charts and so much data at once? But I think it's actually You can see with these 48 charts, again, having no idea what you're looking at, you can start seeing similarities and differences. You can imagine how you can start asking questions either about sets of these charts or about individual charts in a meaningful way. The first version of this was actually something much fancier and much less useful. This had been based on a surface. Those lines are essentially like cutting across the surface. But in practice, we found that it ended up being an interactive tool with these 49 charts, and some interactive navigation was much more effective in practice, even though it seems less fancy. Another way of making small multiples is actually using a different form, but the same exact data. And this one isn't one that our tools support quite as much, but I think it can be a really valuable practice. For example, these are 4 maps of 2009 unemployment rates that show exactly the same data. I'm actually going to talk about these a little bit later when we talk more about color. But you can tell that you might notice different things in these charts, even though it's exactly the same data. And that's because the color mapping that's used is helping us ask different questions. It is intentional and good that we're noticing different things in these charts. And you may want to just choose the one that's best and most appropriate for your analysis, or you may find there's actually value in seeing multiple views at one time. We could look again at some of the weather data. Does temperature correlate with wind direction at SeaTac Airport? And we might make a scatter plot of this with wind direction on the x-axis, temperature on the y-axis. This is, again, a year of observations, hourly observations. And we can notice some things about, like, when it's warm, it tends to be direction more coming from the west. Cooler is other times. We don't get a lot of wind coming directly from the east. But a really typical thing to do with scatter plot like this is to use an opacity, change the opacity to get a better sense of density overall. And when you're doing that, you're actually changing the question that you're asking. With the full opacity, or alpha equals 1, you're asking what has happened at least once in the past year. When alpha equals 0.01, you're asking what is most typical, that we're kind of middle temperatures and getting wind out of the west. And the middle one asks us what is happening often. And I think that's actually valuable. You could ask any one of these questions, but I think there's actually value in seeing all 3 of them together and asking all 3 questions at the same time. Number 2, using color intentionally. I'm going to dive a little bit into pre-attentive processing and how and human perception to introduce this section. So the basic visual attributes are perceived without any conscious effort. This is pre-attentive processing. It's done in parallel, while attentive processing is done serially and is much slower. And I'm going to use some pre-attentive attributes to bring your attention to the word effort, things like color, size, boldness, because a lot of this is about effort. How hard do you have to work? What do you notice without having to think? And these pre-attentive attributes form the basis of a lot of our different chart types. For example, bar charts are all about line length, and we're looking at length, and that's one of the basic pre-attentive attributes. But the one I want to focus on right now is intensity and hue, the 2 things that make up color. And this is an example adapted from Cole Nussbaumer and Colin Ware, and I'm curious if you see any interesting patterns in this set of numbers. And let's ask an easier question. How many 7s are there? And notice, is this an easy question to answer? Are you working hard? How confident are you that you answered this question correctly? Oh no! That's, okay, we'll go with colors. So there's a lot of gray numbers previously. It was hard to see the numbers. Thank you. So we can just jump to what you typically do with a default graph of adding categorical colors. But it's still a hard exercise, although a little easier than when the numbers were invisible. 0 to 9 is ascending, so maybe a sequential scale, color scale is more appropriate. You might notice different patterns this way. Veridus is a popular color scheme, so we could apply Veridus. I think the 9s really pop out when we do this. Maybe we're interested in extremes, so we want to look at diverging from 4.5 and go either more green or more brown, and maybe that will give us more insight into this set of very important numbers. But we know that we want to count the number 7. This is going to be pretty funny because that gray is not going to show up. So let's just show the 7s. It makes the answer really easy, even if your grayscale is not quite white. We can do the same thing with 3s. There's lots of them. This is really funny. There's only one 1. We can use highlighting with small multiples to help see the distribution of different numbers all at once. So combining the concept of highlighting and using color intentionally with the small multiple concept. And if we're doing more general analysis, if we're not just asking how many 7s are there, how many 3s, it is appropriate to look at different color schemes and notice that different color schemes actually emphasize different aspects of the data. And one thing that I noticed with the diverging one is that we have this cluster of middle value numbers in the corner that I don't see pop out as much in some of the other color schemes. So that was a contrived exercise, but I'll show you some things with real data and there's a couple different ways to use color intentionally. I want to start by thinking about using this highlight color to focus attention. So this is the cars data set that's built into R and Python and pandas. And we can see that in 1974, Japanese-made cars had a higher mile per gallon than US models, or US and European combined. And really making a choice here, saying, I want to emphasize Japan compared to the others. So instead of just using 3 different colors as the tool might do naively and by default, because it doesn't know what to do, actually taking a stance and saying, I'm comparing Japan to the other countries. I will make Japan be the focus. The other ones will be differentiated with different shades of gray. There is a light gray up there for for Europe. We'll go with this. You can use highlight colors to see categories in context. There's actually gray scatter plots on all of these showing the full set, but you can also see how highlight colors pop, and it would be popping from the background. So there are, in drama, you actually see all the gray in my screen, but it helps pop out and see things in context. Be careful of light grays. You can use interactivity to focus on one category. This is using the Altair tool in Python, which is based on, of course, Vega, which is developed here at University of Washington. And interactivity combined with highlight color can be a great way to more richly explore a data set in context. Sometimes we make scatter plots that look like confetti when we try to apply as many colors as possible, but using interactivity and highlighting and small multiples together can also help us explore that space more richly and not just kind of have this confetti where it's hard to see distributions. And again, there's gray dots behind all of that for what's not being highlighted. Another way of using color intentionally is to think about the mapping from numeric domain to color range and make that meaningful. So this is unemployment data by county in the US from 2009. This is the default in Altair and does what essentially all default tools will do, tools will do by default of setting your color value from a min to a max. But I think when we do this, I really notice that we all see that one bright county in Southern California. And you can see some other patterns in this data, but I think it's harder to see as rich patterns as if we could make a decision about what we care about more. Part of what's happening here is that if we look at the distribution of unemployment rates by county in this data set, we're actually using half of our perceptual space for only 4.5% of our counties. And maybe that's a decision that we want to make. Maybe that's a good thing, but it should be a decision that we make. And we can make other decisions. So we might say, you know what? Once you have 15% unemployment rate, that's a lot of unemployment. So let's stop our color map there and use our color map to get us from 2% to 15%, and then just kind of flood above 15%. We're making a decision. We're going to flood yellow above that. We're going to flood purple below 2%, and really focus on this 2% to 15% space. And yes, we're making a decision, but we're always making a decision, even when we use the defaults.
I have a comment here. If I actually make this map a grayscale, I can recognize the distribution better.
Okay, yeah.
Not using any color at all.
You're still using color if you're using grayscale, but yes.
So I don't think they're using color effectively in this case.
I think it's really valuable to think about what works for each individual. You do lose some perceptual differentiation by going to grayscale, which is a choice to make. But yeah, I think it makes a lot of sense to also see what works for you. That's a really important part of the context, is what works for you as the researcher. So here we can compare the before and after of that and see if you notice different things. We could also flip the color scheme. So same exact color scheme, just flipping the purple and yellow. And I would argue that I notice different things when I flip the color scheme, even though this is a perceptually even color space, that different things attract my eye and attract my attention. I might notice different things, I might ask different questions. You can try a different color scheme, see if you notice the same things or different things. But perhaps a diverging color scheme is more appropriate. So we can compare what is the unemployment rate compared to the median unemployment rate, where the oranges and browns are higher than median unemployment and the purples are less than median unemployment. But why should the middle be 8.5%? Maybe it makes sense to set the middle at what economists tend to think of as the ideal unemployment rate, something around 5.5% for a healthy economy. And then when we do that, we can see that a lot more of the country is in this orange and brown space. And 2009 was, of course, a very difficult time economically in the United States. And it makes sense that a lot of the country reflects that we see a lot of orange and brown here. We could put in a hard cutoff, say to really highlight areas with greater than 10% unemployment, or to focus on areas with less than 6%. So different mappings ask different questions. You might be at this point and be like, oh my God, everything looks different. How can I trust anything that I see? But I think this is actually a good thing, because when we choose the color mapping, we're actually asking a question. And we do this, even if we don't do this intentionally, we are doing it by default. When you set a color map to min to max, you are asking a specific question. And when you choose a different color map, you are asking different questions. And different questions should, not surprisingly, have different answers. The right color mapping depends on what question you want to ask the data. That's the same in statistics, machine learning, everything else. The parameters you choose change the question that you ask. And when you ask a different question, you should get a different answer. And we should be thoughtful and transparent and recognize the questions that we're actually asking, and choose colors and visual form that match the question that we want to be asking. One of the critiques of different types of color maps is what about like quantitative comparisons? What about perceptual evenness? And I think that if quantitative is the most important thing to you, it's good to use a type of visual form that really emphasizes quantitative comparisons, that uses position for some of that. So this is a map on the left that has unemployment rate on the x-axis, county IDs that you can't see on the y-axis, but ordered by unemployment rate, and you can kind of see what the slope is and where those line up. And by using something like Altair, where you have interactivity, and Vega, you can have this combination where you can still get some of that geographic component and also get a more quantitative component. Because as good as we can make our color maps, color is still a very qualitative type of signal visually. So it's your turn again. For 2 minutes, discuss with the person next to you. Is there a situation where a different color to value map would be better in your work, in your studies? Again, it's the beginning of the semester, so in a chart that you've seen, in a chart that you're interested in making. Let's go. And once again, is there anybody that wants to share a situation where a different color mapping might make their viz better? Any brave volunteers? Okay. Yeah, go for
So
it.
we spoke a little bit about maybe the difference between kind of a quantitative view of a color, just kind of the wavelength of an actual color, and perception, and how those two, how this difference has to be accounted for in this transformation between how things are distributed quantitatively to perception. There may be spots that we like more than others, or that we perceive differently.
Yeah, definitely. Thanks. So diving into the third topic of optimizing for your time, energy, and attention. So one of the things for data processing pipelines, I like to recommend that you have many static charts that are mostly boring, where important stuff is obvious. And this is kind of those situations where we're going to do the same type of analysis over and over again. So you can really invest in your charts up front. And those are often things for like checking data quality, where you're hoping for boring, you're hoping that your data is not broken, but you really, really, really want to see if it is. And in these situations, I think there's a lot of times where having more charts that are well tuned for specific purposes can be easier to interpret than fewer. This is another example from that same project that I did at Google. We actually took one chart and replaced it with 5 charts. And these actually have exactly the same data in every one of these charts. The first one, we set the min to 2nd percentile and instead of the absolute min, so that outliers wouldn't wash out the color scale, and the max to the 98th percentile. But otherwise, fairly standard. And for all those in the room that you see me using a rainbow and are like, I'm done listening to her, this was actually very intentional in this project. We wanted to get as much perceptual differentiation as possible. We were never going to print this in grayscale. We were never going to look at it in grayscale, which is one of the concerns. This was made for one person. The person using it can distinguish red and green with no problem. So in this context, this made a lot of sense. If you're making something where you don't know who your audience is going to be, you have to at least have a fallback for red and green color confusion issues. There's a lot of reasons why you wouldn't use this color scale, but in this situation, I argue is the best one to use. You can reverse the color map since the eye is so since the red is so eye-catching, that you think you notice different things, even though it's exact same data. You'll notice different things in the second one than the first one. And this deals with some of the fact that this is not a perceptually even color scale. In the middle one, we set the min and max to the first standard deviation. So say, hey, let the outliers bleed out, and let's focus on differentiation within the first standard deviation. Really see what's happening in the middle of our color value space. The next one is the max color set of the median, and so we focus on the bottom half of the range. And the last one, we focus on the top half. And every time we do analysis in this type of data, we look at all 5 of these charts together. And this is actually a group of 25 charts because there's 5 other dimensions that we also look at, but I'll just save you that and focus on the one set. And we found that this set of 5 is actually much easier to interpret. We're much less likely to overlook important things by looking at this set of 5 than any single chart. There is no best one because we have different questions based on what's going on. I actually have enough time, so we're going to go to the bonus section. The last topic of guideline is that order matters. You should put things that you want to compare next to each other. And this is the core of a lot of our different chart forms. Things like scatter plots and line charts are all about position. It's all about putting related things next to each other. It's the core of a scatter plot of these things are next to each other because they have similar x and y values. In a line chart, we're actually connecting values that are adjacent to each other. But we have other chart types like bar charts and heat maps where the relative position and order is not well defined. I pulled some data from that 538 article, the Economic Guide to Picking a College Major. 538 is lovely, and they post a lot of their data on GitHub when they can. So the data here that we're going to look at is for different college majors, how many people in the workforce had that major, and how much money did they make by major. And this is a great article. Recommend checking it out. But I just took some of the data from it. I threw it into ggplot. I'm only looking at majors with greater than 20,000 people in the US that are in the workforce. And by default, of course, like almost any tool, the majors are sorted alphabetically by name, because what else would the tool possibly do? It doesn't know what to do. But sorting the majors by name is not necessarily the most meaningful thing we could do. We could instead just actually sort by the metric that we're looking at. So we can see, like, now psychology is on top, the most psych majors overall. And we can kind of see how this distribution falls off, maybe start asking questions about it. We could also sort by a third metric. Maybe we're interested if there's a correlation between how popular a major has been and the median earnings. So if we actually sort the college majors by the median pay, we can start seeing if we see some correlation in the length of these bars. And we seem to not see that. And we can ask questions about why. We can also notice that in the fine print, engineering is not a bad major to choose. There's a lot more, obviously, behind this in terms of the standard deviation and unemployment rates and a million other things that you might be interested in. And also how curious you are about the major and all those good things. But hopefully takeaway is that sorting matters when choosing a bar chart. This is an example by Nicholas Crutchen about seriation technique. This was written in a blog post. He started by showing this matrix. It looks kind of like plaid. But then he used some techniques, statistical techniques, to start ordering it. You might see some patterns start to emerge as he does some clustering and does some more clustering and uses a seriation technique. And in the end, we realized that this is actually a picture of his face. But you might not have guessed that from the first image. And this is really reinforcing, one, that order matters, and that two, statistical techniques can help us order our rows and columns in a better way. The only difference between these is the order of the rows and columns, and yet they mean very, very different things to us. Technique was also used in the distill.pub team at Google on the article 4 Experiments in Handwriting with a Neural Net, where they were doing some analysis on this neural net and different activations and how it interpreted handwriting. And these are two different versions that they show. In the bottom, they actually use t-SNE to order the rows by similarity, and you can start picking out some patterns that were much harder to see above. We'll go back to. So in summary, is it good or bad? Depends on your goals, your context, and your constraints. A few good guidelines are to create small multiples, many related charts, to use color intentionally, and to optimize your charts for your time, energy, attention. And as a bonus feature, order matters. Put things that are related next to each other. So one last 2-minute chat. How can you use one of these techniques in your studies or your work this week? She was looking for the sign-up list. I don't know if it's... If you can hear me, clap your hands once. So anybody want to share about how you're going to use one of these techniques this week? If not, we can jump into Q&A. You can come up and tell me afterwards. Yeah, so we'll open it up for questions.
Well, first I want to thank Zan for speaking to us. This was a great talk. Thank you so much. And we have quite a bit of time, but at the bell in 5 minutes if people need to leave.
Sure.
Sure. I have a question about resources. So do you have any resources you can recommend for visualization and design thinking? I'm thinking particularly in terms of data exploration and building pipelines.
Well, you have some great resources here at the University of Washington. There's a great Viz department. I've recently been reading Colin Ware's book on visualizing for science, that's based on science, so I've been enjoying that so far. Storytelling with data is more communication focused, but I actually think the principles are fantastic, and really love Cole's blog and book blog, podcast, and workshops. Those are a few that come to mind. Tamara Munzer has a nice book on really kind of breaking down a lot of the has a really nice framework for how to think about different types of visualization. But yeah, and especially like you have one of the best Viz groups here on campus, so definitely going for that.
So first of all, thanks a lot for a great talk. I think we would all be interested in knowing that if you can describe to us a scenario where a client has come to you with a problem and you went back, and what was your thought process and how would you use these three principles and how would you propose a solution to a client? And kind of a follow-up question to that is the gentleman here pointed out that a grayscale may work better for him than a color map for you. So how do, when you go back to the client with the solution, do you have multiple solutions in hand to just show them if what best works for them? How do you figure that out? What's the best one?
Cool. So the question, if I got it right, was how to understanding a client's how to think about going from like understanding a problem from a client and what's my workflow for bringing them a solution, and do I bring them multiple solutions, or especially recognizing that there's kind of individual differences or group differences, how do I think about making the solution that works for them? Is that cool? That's a big question. I think that like there's definitely in Viz, like there's a lot of like there's engineering and analysis and design, but communication is a really huge part of the process, especially when you're doing client-facing work, or even like any type of collaboration. Basically, anytime that you're not doing work, that you're doing work for anybody besides yourself, where it's going to be for somebody else or with somebody else, that role of communication is really valuable. And a lot of it is like people don't necessarily know. I think because we all see charts and graphs, people will sometimes come to you with an idea of what they want, but that might not actually, that's an idea coming from like their frame of reference of what the set of possibilities are that they're aware of. But as the expert, you might have a set of possibilities that they're not aware of. And so being able to dig beyond the ask and think about how do I get to the underlying need? How do I understand what's important? And so some of this is kind of user experience principles about watching what they're trying to do, having that conversation about what they're trying to do. Definitely trying to get to the heart of like, and one of the things I really enjoy, especially in the scientific context, is a lot of the Viz process is also, I'm really asking what is important about your data. And that's a scientific question. And using the process of creating the Viz to reflect back to them what they're telling me is important. And if Viz isn't working for them, that maybe we're having a conversation about maybe something else is more important to them. A great example of this was I was looking at something where we had an example where there was, we had 6 categories, and 5 categories were actually in a cycle, and the 6th category was kind of this thing that wasn't part of the cycle. It wasn't in this like circular relationship. And so when choosing a color map for them, really making sure that I had a color map that had this sense of cycle in it, but that the 6th category was actually was intentionally not part of the cycle. And that wasn't totally clear in the first draft, but they reflected that back. And I was like, oh, actually, like, that makes sense. We can design a color form that reflects that truth. So I think, yeah, that was the 10-minute. If people.
So this is normally where we start questions, so we still have about 10
Cool. Does that answer your question? Sorry. Cool. Here.
Yeah, great talk. You showed a slide, I think it was the first one in your talk, about some freelance work you started. I'd just be interested in hearing your career path and what led you.
Yeah, I think it's a really interesting space right now in Viz, where a lot of people that are doing Viz, like when I was an undergrad, there was no data viz classes at my university. Data viz wasn't a thing that one could major in or even take classes in. And I think, I mean, it's really exciting now that there's so many more opportunities at the undergrad and graduate level for studying these topics. So for me, I went to Williams College, which makes the purple and white W's kind of confusing because we're also a purple, or purple and gold W. I majored in math, and I actually see, even though I majored in abstract math, so there was no data to be found, and no numbers most of the time. But I actually feel very similarly about, in math, I really loved the idea of getting to the core of the problem. When I was trying to prove something, it was about getting to like the heart of understanding the set of ideas. And I actually feel very similarly, part of the data that I love is getting to like the heart of what is important about this data. And so even though it's very different ways of experiencing that, I actually feel some very, like, I like both parts of that. I took a circuitous path. I taught high school math for a couple of years. Turns out teaching pre-calculus was really great for using D3 many years later, because there's a lot of transformations in 2 dimensions, which is a very core part of pre-calculus. And a lot about communication as well, how to communicate.